Hello everyone and welcome to a Kuta worksheet tutorial. We're doing properties of exponents, so let's get right into it. Now we're only going to do, there's a lot here and you'll kind of get the idea once we do a couple of them. So we're going to start easy and I'm going to work my way through just a select few so you get the general idea on how to do this on your own. Now when you're approaching these problems, first thing I got to identify is you have to identify the coefficients. These are the numbers out in front, okay, not the variables. 99.9% of the time, you're just going to be multiplying these together. So we see that everything's multiplication. We have 2 times m squared times 2 times m to the third power. We're just going to multiply the two coefficients together to get 4. Now, the tricky part, well, it's not so tricky, but it just requires a little bit more patience, I suppose, is we have the variables. So we have m squared times m to the third. I'm going to show you real quick the long way, and then I'm going to teach you the shortcut. So the long way would be writing out each one in terms of what it means. So m squared means m times itself 2 times. M to the third power means m times itself 3 times. So in total, we have m times itself 5 times. So we're going to get 4m to the third, or sorry, fifth power. I just said it. Now the easy way to do it, though, is to just add the exponents if you have like bases. So we have like bases, m and m are the same. So we can add 2 plus 3 to get 5. And that's how we arrive at our answer a little more quickly. Let me demonstrate it again a little more quickly this time. Okay, so let's go to this one, number 2. We have our coefficient. This time we only have one coefficient. So we're going to put, what color was I using before? Purple? Green? Whatever. Okay. I'm just going to use, I don't like orange that much. Use green. So we have 2. So I'm going to put 2 there. And then we have m to the fourth times n to the negative third power. Okay. We have like bases. That's fine. And then that means we can add exponents using the powers rule. So 4 plus the negative 3 equals 1. So we keep the base the same, make it 1. Or just leave that equal to 2m. And that's our final answer. All right. Now we're getting a little more difficult because here's a big hint, a big clue. We're only supposed to be using positive exponents. So far, we only had positive exponents, but let's see what happens as we get a little bit more complex. Here we have 4 and 2. We're going to multiply these together first, our coefficients out in front. 4 and 2, 8. Then we have r to the negative 3 times r squared. Okay, powers rule. We're going to have negative 3 plus 2 equals negative 1. Now, it said we can only have positive exponents. So we have to understand what negative exponents mean before we can continue. Anytime we have a negative exponent, it means we're going to put it into the denominator. Okay? But if it's in the denominator, we're going to move it up to the numerator. Essentially, you're thinking fraction anytime you have a negative exponent. Don't think negative or positives. Think fractions, ratios. So we're going to have 8 here. 8 stays by itself. He's fine. He doesn't have any exponent going on with him. Just leave him alone. But the r to the negative 1 is technically 1 over r to the first power. So we can, I'm just going to write it out this way first so you get the idea. R to the first power, that's the same thing as 8 times 1 over r. That's the same thing as 8 over r. Okay, now the way I like to do it is I think, okay, I have a negative exponent, so I'm going to immediately put a line here. And what I'm going to do is I'm going to take the negative exponent, which is this guy, and I move that whole term down to the bottom, like that. And then it becomes 8 over r. And that's our final answer, okay? I'm going to do another one just so you can get the hang of it. So let's look for more negative exponents. All right, here's a good one. We have negative exponents. We're not going to get anything in the bottom, but that's fine, okay? We have 2 times 2 out in front. That's going to be 4. Then we have x cubed. Let me change the colors here. We have a lot going on. X cubed and x to the negative 1. We're going to do 3 plus the negative 1. That's x squared. Then we have, let's go blue. We have y to the negative 3 and y to the third. That's y to the 0. Now we have to simplify here. How do we simplify this? Well, 4x squared, that's fine. But y to the 0 is just 1. Times 1. Anything to the 0 power is 1. So if we had 100 to the 0 power, that equals 1. If we had negative 5 to the 0 power, it's equal to 1. If we have x to the 0 power, it's equal to 1. So y to the 0 power is just 1. Essentially what that means is we don't end up writing it. We just get 4x squared, and that's our final answer. So there's that one. Let's take a look. I'm going to do like maybe one more from this side. Okay, I'm going to do this one similar. Let me go ahead and do number 9. So we're going to multiply 4 times 3. We get 12. Then we have a to the third, and we get a to the negative fourth. We're going to do 3 plus negative 4. That's a to the negative 1. I will change that later. B squared. So I'm going to add these ones now. Let me change the color. 2 plus the negative 3. That's b to the negative 1. Okay. What do? I like making the line. And I'm going to move this guy down, and I move this guy down. The 12 stays up. So 12 stays on top, but we move the a down, a to the first power, b to the first power. Because remember, we have to write in only positive exponents. So we get 12 over AB, and that's our final answer. Okay, so that's how you do these a little bit more complicated ones. Now I'm going to show you these ones down here. So anything to the 0 power, I already said is 1. So if you have parentheses to the 0 power, it's just going to be 1. Okay, let's go to number 12. Here we have a negative 4 outside. So that means we have to essentially, it's kind of like you raise the power of each different product inside. So we're going to raise 2 to the negative 4th power. It's almost like the distributive property. And x squared, sorry, to the negative 4th power. We have two things to the negative 4 power. So essentially what we can do is if you have the negative 4 there, we put it here, we're going to move this whole thing down to the bottom. Okay, and then what's left in top, not a 0, but a 1. Okay, let me show you individually. So this 2 to the negative 4th becomes 1 over 2 to the 4th. And this x squared to the negative 4th, we're going to, this is our power rule also. Anytime you have an exponent raised to an exponent, power raised to a power, you're going to multiply exponents. So you're going to get x to the negative 8 power. Okay, so that's 1 over 2 to the 4th. I always like putting my line, whoops, and moving this guy down. So this becomes x to the 8th power in the bottom. So we have, what is that, 16? 1 over 16x to the 8th power, and that's my final answer. More of these. We distribute this 4, so we get 4 to the 4th power, and then 0 times 4, power raised to a power multiply, we get r to the 0. That's just 1, so we just get 4 to the 4th power. I think that's, what is that, 4 times 4, 16, 464, 256? Pretty sure it's 256. Could be mistaken, but no, it's not. I think it's 72. It is 72. So we get 72 for our answer. Anything to the 0 power, that's the key, is going to be 0. Okay, this whole thing raised to the negative 1. Again, if you have a negative, we're going to put a line there for a fraction. Move this whole thing underneath. Don't forget the 1 on top if it vacates that whole top. So we get equal to 1 over 4xy to the first power. We can get rid of anything to the first power. Get rid of the exponent and just leave it 1 over 4xy. All right. Let's go ahead to... I'm going to go ahead and keep cruising. If you're done, you're good. We'll go ahead and leave this video, but I'm just going to do a little bit more. If there's 3 terms, same thing. We distribute to all 3 of those, but because it's only to the negative first power, we just flip it. So we put a fraction, put this in the bottom. It's to the first power now, so 1 over 2x to the 4th, y to the negative 3rd. This one's going to actually be pretty interesting. To the first power. So anything to the first power is just itself. So we have 2x to the 4th, y to the negative 3. Now, here's the thing. We have to move this guy because he's negative. We can't have negative exponents, so we're going to move him from here to the top. Remember, anytime it's a negative exponent, it moves from either the top to the bottom or from the bottom to the top. So this becomes y cubed over, and the 2x to the 4th stays in the bottom, and that's our final answer. Let's get to some fraction ones. These, in my opinion, are easier than they look. Okay, so for example, number 22, if we have a negative exponent, we need to move it to the bottom. If it vacates the whole top, we need to put a 1 up there. So we have 4x to the 4th, and now we have a x to the first power down there. And now we have the power rule. So we're going to 1 over 4x to the fifth power because we add the exponents. And there's our final answer. Let's go to a really tough one. Maybe this would be a good one to end on. I don't want to spend too much of my time just chirping at you. Real quick advice on maybe this one. Just cross off x to the 0, y to the 0, z to the 0 for those ones because they just turn into ones. Okay, but for number 26, we're going to do this one. First thing I'm going to do is I'm going to just circle all these negative exponents and point them in the other direction. Some people like doing subtraction first because there's divide. So I'll show you how to do that afterwards. But I like moving them up and around. So we have 2x to the 4th, and then it got joined by y to the 3rd. I made it positive because I moved it. Then I had 3x squared, and then I have that y 4th because it was negative on the top, moved to the bottom to become positive. Z to the 4th power, and then I have that z cubed that moved down. So let me change the color of these ones so you see which ones I moved. I'll change it to green. Okay, so you can see that this one, I'm going to change this one here a different color still. Let's make this one pink. Okay, so this y cubed got moved, so he became positive from negative. And then I had these two green ones, this one and this one, style, and those were green. Okay, so you can see where they moved from and how they became positive. Okay, and then from here, all we're doing is combining, and it's much easier this way. So what we have going on here, we have 2x to the 4th y cubed over 3x squared y to the 4th, but then we have z to the 7th. Now, this is what I like to do for these, is I like to cancel. Some people like to do the quotient rule, which is if you have x to the 4th over x squared, that's the same thing as x to the 4 minus 2. So then they just do subtraction the whole time. And you can do that right from the get-go. That's what I was alluding to earlier. If you have y to the negative 4th over y to the negative 3, you could get y to the negative 4 minus a negative 3. You can see why I don't like this method. It's a little cumbersome, in my opinion, to get y to the negative 1. I don't like it because I lose track of where it was in the top, was in the bottom. So I just like drawing the arrows like you saw me do earlier. I'm going to keep this just in case you want to copy this down and be like, hey, my teacher taught me this way. Why are you doing it like that? So now you see it, okay? Don't be saying that I'm teaching you the wrong way. I'm teaching all the ways that I know, and you get to pick which ones you like. I feel like that's pretty fair. Okay, so then we have x to the 4th over x squared. What I like to do is this. I'm going to cancel two of these. I always look for the smaller number, okay, with the variable. So I identify the x's, okay? I'm looking at the x's. Where's the smaller one? The smaller one's in the bottom, so I'm going to cancel both of those with two of those. So two of those with the 2 in the top. So 4 minus 2 is 2. Okay, I'm going to identify my y's now. Here I have y's, here I have y's. I'm going to identify the smaller one. The smaller one's in the top, so I'm going to cancel 3 of those with 3 of these, leaving me just 1. And then there's no z's in the top, so I don't need to cancel there. So my final answer is going to be 2x squared over 3yz to the 7th power. And there you go. A little bit complex. I'm sure you guys are going to have questions on these. If you need me to do any more, let me know. But this is the process for like these big ones. It's a little bit involved. Stay organized. You got this. Thank you for watching. Hope to see you soon.